Today we're talking about the chain rule, which is another tool that you can use to take the derivative of functions. So today the functions are a little bit more complicated, so that's why you need another tool in your toolbox in order to take the derivative. So use the chain rule if you have y is equal to u to the n power, where u is something more than just x. So if you look down at the example, we are raising x to the third power plus 1 to the second power. So this is something that's more than just x. Like it's a little bit more complicated. I'm like cubing it, adding a number to it, so it's something that's more complicated than just a variable. So when you have something like that and you're trying to take the derivative, you use the chain rule, which is where you take your exponent, pull it out front, just like normal, keep u, so keep this the same, subtract 1 from your exponent, but then you have to multiply by the derivative of u. So whatever is your u, you have to multiply by the derivative of that. So let's do an example. Y is equal to x to the third plus 1 raised to the second power. So I'm going to have to use my chain rule. So I'm going to take the exponent, 2, pull it out front. I'm going to keep the insides the same. I'm going to subtract 1 from my exponent, which is b to the 1 power. And then now I have to take the derivative of what's inside my parentheses. I have to take the derivative of u, which is 3x squared plus 0, so it's just 3x squared. So my final answer, I can multiply the 2 and the 3 to get 6x squared times x to the third plus 1. If you wanted to, you could then distribute the 6x squared, so you can get 6x to the 5th plus 6x squared. Pause your video, try this U-try problem on your own. Use the chain rule to find the derivative of f of x equals 2x minus 3x to the third, all of that to the 4th power. Pause your video, copy this down, try to take the derivative of this on your own. Alright, so when I take the derivative using the chain rule, I'm going to take my exponent 4, pull it out front. I'm going to keep the insides the same. I'm not going to touch it. 2x minus 3x to the third. Then I have to subtract 1 from this exponent, which is 3. And then last, I need to multiply by the derivative of u, whatever's inside the parentheses, which is 2 minus 9x squared. So, final answer, I'm just going to distribute the 4. Well, I don't even have to do that. 4 times 2 minus 9x squared times 2x minus 3x to the third cubed. You can just leave it like that. You don't have to expand it out. Alright, let's do another example. G of x is equal to 3 times 3x squared plus x cubed all to the 5th. So this is my u. Sometimes it's helpful to be right. Like this is u. So u prime would then be 6x plus 3x squared. Alright, so I'm taking the chain rule, or using the chain rule, taking the derivative. G prime of x. I'm going to take my exponent and pull it out front. Well, I already have a 3 as my leading coefficient, so 5 times 3 is 15. I keep the insides the same, 3x squared plus x cubed. I'm subtracting 1 from my exponent to get 4, and then I'm going to multiply by the derivative of u, which is 6x plus 3x squared. And I can just leave it as my final answer. You try this one, pause your video, copy this down. You try, find the derivative of y equals 2 times 3x squared minus 2x to the 4th power. Alright, so when you take the derivative, y prime equals, take your exponent, pull it out front, 8 times 3x squared minus 2x. You gotta keep that inside the same, can't touch it. Subtract them from your exponent to get 3, and then you need to multiply by the derivative of what's on the inside, which would be 6x minus 2. Final answer is totally fine.